All right, let's just jump right in. If you've ever felt totally overwhelmed by Kubernetes, wondering how all the pieces fit together, you are in the perfect spot. We're about to make the core concepts of K8s finally click for you. I'm convinced that something like 90% of people learning Kubernetes get stuck on the very same three things: pods, deployments, and services. And it's not their fault. It's because nobody ever takes a second to explain the actual relationship between them. Well, that all changes right now. In the next few minutes, I'm going to give you the mental model that took me years to figure out, and I promise it's going to make everything fall into place. But wait, before we even talk about pods, you need to burn this one sentence into your brain. Ready? Everything in Kubernetes is just an API object stored in a database. Seriously, once you get that, the rest is easy. So what does that actually mean in practice? It means that at its heart, Kubernetes is just a big, powerful central brain called the API. Think about it this way. When you run a command like kubectl apply, you're not doing some kind of magic. You're just an API client. You're sending a plain old HTTP request to the API server, saying, hey, this is the state I want. The API server then just saves that request into its database, which is called etcd. And check this out. This is how those API objects are organized. Now listen up, because this is a huge exam favorite. The simple rule is this. app/v1 is for things that manage your application, like a deployment. But the most basic building blocks, pods and services, they're so fundamental, they're in the core API group, just v1. Knowing that one little detail will get you a couple of free points on any certification exam. I guarantee it. And hey, if that little API version tip just made a light bulb go off for you, do me a quick favor and smash that like button. Let me know down in the comments with API clicked. It really helps me know what's hitting home for you guys. Okay, with that API foundation in place, we can finally talk about the smallest, most fundamental building block in the entire Kubernetes universe, the pod. Now, pods can feel a little abstract, so I'm going to give you the best analogy you'll ever hear. Just think of a pod as an apartment, and any containers you put inside that pod, well, they're the roommates. This isn't just a cute little story. It perfectly explains how they actually function. See, just like roommates, all the containers in a single pod share everything. They share the network, same IP address, which means they can just talk to each other on localhost. They share the storage. They can all see the same files and volumes. And this is a big one. They share a life cycle. They're created together, and they die together, always. And speaking of that life cycle, it's pretty simple. A pod starts as pending, while Kubernetes finds a home for it. Then it goes into running once the containers are up. And finally, it's either succeeded or failed. Now, if your container keeps crashing over and over, that's when you'll see the dreaded crash loop back-off status. We've all been there. Okay, here it is. The single most important thing to know about pods, and the reason you almost never create them directly. Pods are ephemeral. That's a fancy word for temporary. When a pod dies, it's just gone. It does not self-heal. If the server it's on goes down, that pod is gone for good. And for a real application, that's a massive problem. So how do we fix this? We use a higher-level object to manage the pods for us. We tell a deployment what we want, and the deployment acts like a manager, using something called a replica set to make sure the right number of pods are always running. This is the next layer of our mental model. So let's talk about that deployment. If the pod is the apartment, think of the deployment as the apartment building manager. It's the one in charge, making sure everything is running exactly the way you want it to. Deployments are fantastic because they solve three huge problems for you. First, self-healing. A pod dies, the deployment controller notices and spins up a new one instantly. Second, scaling. Need to handle more traffic? You change one number from 3 replicas to 10 and you're done. And third, updates. How do you update your code without taking everything down? Deployments handle zero downtime updates automatically. Now, when it comes to those updates, rolling update is the default for a reason. It's your best friend. It gradually replaces the old pods with new ones, so your users never see any downtime. The recreate strategy, on the other hand, kills all the old pods before starting the new ones. You'd only use that if you absolutely have to, because it will cause an outage. So let's put that together. You manage the deployment, and the deployment worries about the pods. If that hierarchy makes sense, you should definitely subscribe, because we're about to add the final, most important piece of the puzzle that makes this whole thing work in the real world. So we've got our self-healing, scalable pods, all managed by a deployment. We're all set, right? Perfect system? Well, Not quite. We've actually just created a brand new, massive networking problem for ourselves. Think about it. Because our pods are ephemeral, every time a deployment replaces one, the new pod gets a completely new and random IP address. So how is anything else supposed to talk to our application? It's like trying to call a friend whose phone number changes every 5 minutes. It's impossible. And that is the entire reason this service object exists. It's the elegant solution to this problem. A service creates a single, stable IP address and a DNS name that never, ever changes. It's the permanent address for your application. It uses labels to find all the right pods and then automatically load balances traffic between them. And you absolutely have to know these service types, so get your screenshot button ready. ClusterIP is the default, perfect for internal-only traffic. NodePort is great for quick development and testing. LoadBalancer is what you use for production web traffic. It actually tells your cloud provider to create a real load balancer. An external name is just a handy DNS trick. Okay, we have covered the holy trinity. But before we put it all together, there's one last little concept that's going to keep your cluster nice and organized, and that's namespaces. The easiest way to think about namespaces is as virtual clusters living inside your real cluster. They let you carve out little walled-off sections. You could have a dev namespace and a prod namespace, or give Team A and Team B their own separate spaces to work in so they don't step on each other's toes. And that's it. We've done it. Let's put this all together one last time and lock in this mental model for good. So here it is, the Kubernetes holy trinity. The pod is the apartment where your code lives. The deployment is the building manager, keeping everything healthy, scaled, and up to date. And the service is the stable street address, so other applications can always find it, no matter what. To really burn this into your memory, do me a favor and drop a comment right now with pod to deployment to service. And make sure you're subscribed because in the next explainer, we're covering stateful sets, daemon sets, and jobs. And trust me, choosing the wrong one of those can make your app fail in some truly spectacular ways. You don't want to miss it.